Hello everyone, welcome to Wings of Physics. Myself Deepali Kulkarni from PVP Junior College, Pravaranagar, Loni. We will continue our topic electrostatics and today's lecture is lecture number 3. In this lecture, we will study the concept of a electrostatic potential energy and its expression. Okay, let us start. What is the concept of electrostatic potential energy? Suppose this is a source charge or it is also called as a point charge. What happens? Point charge or source charge, it produces a field around it. Then another unit positive test charge. Suppose this is a unit positive test charge. Bring into that field. Then when the two charges, they are positive charges, at that time there is a force of repulsion. Then this is the direction of force of repulsion in between these two charges. And if we have to move this test charge against this force of repulsion, at that time we have to do some work on it. And that work, suppose we have to displace this test charge through some distance, at that time we have to do work against this electrostatic force of repulsion, and this work that is stored in the form of a electrostatic potential energy. Okay, I repeat, when a source charge is there, it produces field around it, then test charge is moved in this field. Then at that time we have to perform a work done against this force of repulsion, and this work done is stored in the form of electrostatic potential energy. And when we travel in this direction, at that time electrostatic potential energy goes on increasing. Understood? Now we have to obtain derivation for this electrostatic potential energy. For that purpose, we have to consider a figure. This is a figure. In this figure, the plus Q, that is a source charge, then it produces a field, and in that field plus Q, that is unit positive test charge is there. Then there is a force of repulsion, and we have to bring this charge against this force of repulsion. At that time that perform work done, that stored in the form of potential energy. Then this change in potential energy, that is du, that is nothing but the work done. This is dw, and we displace this charge through this small distance dr. At that time the work done, that is nothing but force into displacement, the scalar product of the force, vector force and displacement. Then force is Fe and dr is the distance. Okay. Then if dot product is there, then product of magnitude of two vectors means Fe into dr is there, and the cos 180 degree, because they are oppositely directed, and cos 180 degree, that is nothing but -1, and it becomes dw, that is Fe minus Fe into dr, means this negative sign indicates that they are oppositely directed. Okay, and this is the small work done in between these two vectors while displacing this charge through distance dr. Then total work done, then we have to displace this charge through from A to B. Then this distance is, the distance A is at distance r1 from this charge, and the point B is at distance r2 from this point charge. Then total work done displacing through this distance, that is nothing but the integration of this, and that is total work done that's stored in the form of the change in potential energy. Then integration within the limit R1 to R2 of this du. Then the integration value of du, that is nothing but the Fe into the dr. Okay, minus Fe into dr, limit of integration R1 to R2. Then according to the Coulomb's law, the force of repulsion in between these two charges, that is nothing but the Fe, product of magnitude of two charges, 1 by 4 pi epsilon naught, that is Coulomb's constant. These two charges Q and Q0 and square of the distance between them, that is R square. If we substitute value of this Fe, then in vector form we have to write a unit vector in the direction of dr, because we have to write this for in vector form, and therefore the du, that is nothing but integration within the limit R1 to R2 minus 1 by 4 pi epsilon naught Q into Q0 divided by R square into R cap into dr. Then the R cap into dr, R cap into dr, the scalar product, again product of magnitude of two vector, magnitude of this unit vector, that is 1, then magnitude of this dr, that is dr, and angle between them, that is cos 0 and cos 0 degree, that is nothing but 1, means it becomes dr, and R cap into dr, that is nothing but dr, and delta u, that is equal to, then this minus 1 by 4 pi epsilon naught Q into Q0, that is constant, and integration within the limit R1 to R2, that is 1 by R square into dr, and that is nothing but, okay, this delta u, that is equal to minus 1 by 4 pi epsilon naught Q into Q0, and integration of this R square, that is nothing but the integration of R raised to minus 2 into dr, that is nothing but R raised to minus 2 plus 1 divided by minus 1, that is equal to R raised to minus 1 divided by minus 1, and R raised to minus 1, that is nothing but 1 by R, and this minus 1, that is nothing but minus 1, and limit of integration is R2 and R1. Then this minus minus, it become plus delta u, that is equal to 1 by 4 pi epsilon naught Q into Q0, 1 by R2 minus 1 by R1. Okay, and this is, if we write here this Q into Q0, then this is the work done, and this work done is stored in the form of electrostatic potential energy. Now, if these two charges are, instead of Q and Q0, that charges are Q1 and Q2. Okay, and the distance R1 is equal to infinity, R1 that is equal to infinity, and means we have to bring that charge from infinity to the distance R, means R2 that is equal to R. At that time this derivation becomes delta U, that is equal to 1 by 4 pi epsilon naught Q1 into Q2, value of R2 that is equal to R, and this R1 that is infinity, 1 by infinity it becomes 0, means 1 by R2 that becomes R, and this is the derivation for change in electrostatic potential energy. Now, what is the definition of change in potential and electrostatic potential energy? Electrostatic potential energy, that is a work done, this is a work done against electrostatic forces. For what purpose? To achieve certain configuration of a charges in a given system. Okay, I repeat, configuration means मांडनी करने. आपल्याला ज्यावेळेस ह्या चार्जेस हे सरकवायचे, त्यांची रचना करायची, त्यांची मांडणी करायची, कशाच्या अगेन्स्ट? या इलेक्ट्रोस्टॅटिक फोर्सेसच्या अगेन्स्ट. तर त्यावेळेस जे वर्क डन घडतं तेच वर्क डन तिथं कशाच्या स्वरूपात साठवलं जातं? इलेक्ट्रोस्टॅटिक पोटेन्शियल एनर्जीच्या स्वरूपात साठवलं जातं. आणि म्हणून काय डेफिनेशन केली जाते? इलेक्ट्रोस्टॅटिक पोटेन्शियल एनर्जी इज द वर्क डन अगेन्स्ट electrostatic force to achieve certain configuration of a charges in given system. Okay, then this is the definition. Then what is the unit? SI unit of this electrostatic potential energy, that is joule. 1 joule, that is the SI unit of this electrostatic potential energy. We have to define this 1 joule unit. What is the definition of 1 joule? 1 joule is the energy stored. This is the energy stored in moving charges of 1 coulomb. 1 joule is the energy stored in moving a charge of 1 coulomb. Suppose this charge is 1 coulomb. Through a potential difference of 1 volt, means the potential difference in between these 2 points, that is 1 volt. 1 coulomb charge is there. At that time electrostatic potential energy is 1 joule. That is the definition of 1 joule energy. Then the another unit, that is 1 electron volt. What is the 1 electron volt? What is the definition of 1 electron volt? 1 electron volt, that is a change in kinetic energy of electron. That is, suppose charge is electron, then the 1 electron volt is change in kinetic energy of electron while crossing 2 points maintained at potential difference is 1 volt. Okay, 1 electron volt is the change in kinetic energy of a electron while crossing the 2 points maintained at a potential difference of 1 volt. Then relation between volt and joule, that is 1 electron volt, that is 1 equal to 1.6 into 10 raised to minus 19 joule. Then another unit of this potential energy, that is 1 milli electron volt. Then this milli, that is nothing but minus 3, and it becomes 1.6 into 10 raised to minus 22 joule. Then 1 kilo electron volt, at that time kilo means 10 raised to 3, and it becomes 1.6 into 10 raised to minus 16 joule. And 1 mega electron volt is there. Mega means 10 raised to plus 6, and it becomes 1.6 into 10 raised to minus 13 joule. And these are the different units of the potential energy. And as we goes through this distance, at that time in this direction the potential energy goes on increasing. It is maximum at this point and it is minimum at infinity, because we consider the infinity point, that is point of a zero potential. Understood? And this is all about the electrostatic potential energy. If you like my video, then like, share and subscribe my channel, and also press the bell icon to get notified about my new upcoming videos. Thank you.